Good morning, mathematicians. It is week 25, and we're looking at our Monday one. We're going to start with some multiplying of decimals. So first of all, I am thinking about 4 tenths. And I am going to think about how 4 out of 10 of these would show 4 tenths. So notice, boys and girls, I'm going to do this a little bit differently this time, just so that we can see a different way of representing this. Notice, boys and girls, I have boxed 4 out of 10 of my columns vertically. Now I'm going to show 9 tenths, but I'm going to show those in rows. So boys and girls, if I boxed 9 out of 10 rows, I would be boxing that much of the entire grid. Now notice, boys and girls, this is the moment that I'm actually going to start shading today. Today I am modeling this by only shading this area where the overlap occurs. The overlap of my 4 tenths and my 9 tenths is right here at that moment. If I counted those individual squares, I would count 36, and I know those are hundredths. That is our first question. Our second question is different. We are actually shown the shaded area, and we are to find the representations. So there's a couple ways that I can look at this. First of all, I can look and see, look, there are 4 holes. Here is a hole this way. Here is another hole. Here is another hole. Here is another hole. So I see on the very top, I am labeled with a 1 here, but I have that repeated in this column and the third column and the fourth column. So I could zero in on the column itself, and I could look and see, well, what do I have in this column, right? How many do I have shaded? 1, 2, 3, 4, 5. There are 5 that are shaded, but each of those shaded parts equal what? Well, I have to look over here to see that, oh, look, 2 of these together equal 1 whole when I look at the rows. So I have 5 halves that are shaded. I have 5 individual rectangles. Each of those represents a half, and that is redone here for the second time, here for the third time, here for the fourth time. So this one, boys and girls, shows me 5 halves repeated 4 times. That's how I know that that one is true. Now, I can also look at this, and as we already said, if this is 1, then in all of my columns, I see a total of 4, right? I can look at my rows to see how much is shaded horizontally. And if this is 1, then this is 2, and there's 1 more half. So I can see over here 2.5, right? Or 2.5, 2 and 5 tenths. Well, when I look at that, boys and girls, I don't see that matching exactly. Oh, wait, I see it here because I have 4 shown in my column and I have 5 halves shown over here because 2.5 equals 5 halves. So boys and girls, I can also circle I. Those two match. The other two are not an expression of what is represented. All right, let's come to the value of the following. If I have 1 whole and I divide that up into hundredths, how many hundredths do I have? Well, I have exactly 100. Now we say, okay, if I have 1 whole and I break it up into groups and I have 200ths in the group, well, if we know that there are 100 hundredths in one and we group those 100 into groups of 2, pairs of 2, I actually now have 50. Now, think about this one, especially in comparison to what we just did up here. If 1 divided by 100th gave me 100, then 2 divided by 100th should give me 200 because in 2 wholes, there are 200 hundredths. Okay, now let's come to this one. Again, we can take this problem and compare it here to our double I. If I have 2, and I want to take all those 200 hundredths and I want to break them up into group of 200, 200 in those groups. How many will I have? We'll all have 100 because if there are 50 in one, then there are 102. Okay, we can look at those also with kind of their partner problems to help us answer those questions, kind of like that. Okay. All right, going to go down below. We are thinking about creating some problems with playing with kind of powers of 10, multiplying by 10. Notice here, if we have 4 and 2/10 times 3 and 1/10, we can multiply this by 10 to get 42. We can multiply this by 10 to get 31. And then after I know the answer to this, then I'll have to remember to go back to where my decimal should be placed. I really had one decimal value here and one decimal value here. So my answer should have 2 decimal values. Sure enough, when we do that, we get 2 decimal values in our answer. After we think about this is really like for our reference. Now we're going to use that same strategy to solve. So first, I want you to use your strategy for multiplying to find 82 times 45. Once you have that answer, resume the video. The answer to that, when solved correctly, should be 3,690. Now, I have to remember that this was not actually 82 holes by 55 or 45 holes. So I have to go back and now take my 3,690 and I'm going to multiply that by those 2 decimal place values. I'm going to multiply it by 100 because I had one decimal here and one decimal here. Now, when I do that, I'm going to get the same digits, 3690, but I'm going to place my decimal so that I have my 2 decimal place values. So I know that my answer to the problem is 36 and 9/10, or we could keep it as 36 and 90 hundredths because we certainly know that those are equivalent values. Algorithm forgot how to count. He needs you to arrange the numbers from least to greatest. Well, first of all, I can see clearly that this and this and this have a hundred place. So those are not among the least. This is among the least and this is among the least. But the difference is right here in the tenths place. That tells me what I need to know. I know that this number is going to be the least. Sure, it has lots of digits in the decimal value, but the tens place is the largest bang for the buck, right? That is what gives this away that this is smallest. So this is going to be the very first in my list, 44 and 333 thousandths. This is going to be second in my list, 44 and 4/10. That's second. Now I'm going to look and decide which of these numbers that do have 100 digits, which is going to be the third, right? The middle of the list. This gives it away because both of these have a 4 in the 100, a 4 in the 10. This one has a 3 in the 10. So this one is going to be my middle value in my list because without even consulting anything else, I already know it's 10 less than these two. So now I have to decide, is this one going to be my greatest value or is this one going to be my greatest value? And just like the 3 gave it away before, the 3 gives it away again. This is going to be my largest because I have a 5 in the tens place. This is going to come before it because it has a 3 in the tens place. I remember that when I list my values from least to greatest, I do write them in order, nice and tidy, and I separate them with commas. And I'm even going to draw a little line just to make sure that I separate. This was kind of my scrap work, my reference, so that I can examine place values, align. This is really how we give our answer, particularly if you were typing this in for a short answer, if you were typing this in to give your answer in that format, make sure that you include that in a nice list and pay attention to the wording. This was least to greatest. So my smallest is first, followed by those growing values all the way to the largest. We can also say that this is ascending order.